Okay, let's dive right into this explainer. Today, we're going to solve a pretty common mathematical mystery. What does the word average actually mean? We hear it literally everywhere, right? In the news, business reports, just everyday conversation. But the reality, the concept of the middle is way more nuanced than just that one single word suggests. Because think about it, there's this kind of dangerous vagueness in everyday language, and it can easily mislead us. Like when someone says the average income in a town went up or the average test score was a B, what math are they actually using behind the scenes? Depending on the specific tool they chose, they could literally be telling you two completely different stories about the exact same data. So, to clear up all this confusion, we're going to unpack this step by step. First up, measures of central tendency. Second, calculating the mean. Third, finding the median. Fourth, identifying the mode. And finally, number 5, we'll see which one is actually best. All right, section 1, measures of central tendency. So the big three, or the three M's, mean, median, and mode, are really just three completely different ways of describing central tendency, or, what we casually call the average of our data. They are completely distinct statistical tools. And when you combine them with range, which just measures how spread out the data is, these tools basically summarize massive groups of numbers into really digestible, important characteristics. Moving on to section 2, calculating the mean. Now, this is often referred to as the arithmetic mean. And this method, it requires every single data point to pull its own weight. When most people casually throw around the word average, this is exactly what they're talking about. You basically take the entire weight of the dataset, sum it all up, and then distribute it equally across the total number of data points you have. To put that into perspective, using a specific example from our sources, the absolute crucial point is that you sum everything up. So say you get a total of 206 from a set of 8 random numbers. You then divide that sum by your count, which is 8, and boom, you get 25.75. It's incredibly precise. It factors in every single piece of data you collected. But, as we're going to see a bit later, including every single piece of data isn't always a good thing. Okay, section 3. Find in the median. So, unlike the mean, the median honestly doesn't care at all about the actual numerical value of every number in the set. It only cares about location. It basically just wants to know who is standing right in the middle of the line. The median is literally the midpoint of your data set. Now, the absolute most important rule here, and you can't forget this, is step 1. You absolutely must order the numbers from least to greatest. If you skip that, your median is going to be completely wrong. So once they're ordered, you find the middle. But here's the trick. If you have an even set of numbers, say 8 or 12 numbers, there isn't one true physical middle, right? So in that case, you actually have to average the two center numbers to find your median. Actually, I absolutely love this real question from a learner in the Khan Academy comments because it anticipates a super common edge case. They asked, what happens when you go to average the two middle numbers? But they're exactly the same. Well, the answer, sourced right from the community, is that even if the numbers are identical, you still take their average. So in their example, it leaves you with 23. You just add 23 and 23 to get 46, divide that by 2, and yep, you're right back at 23. It might feel a little redundant, for sure, but strictly following this mathematical rule ensures your median is always perfectly accurate. All right, let's look at section 4, identifying the mode. The mode is kind of the forgotten middle child in everyday conversation, but it's actually the most straightforward idea of the whole bunch. It simply asks, what shows up the most? That's it. You don't have to sum anything up, you don't have to find the physical center, you literally just count frequencies. For instance, looking at this frequency table from a golf score example in our sources, it's incredibly easy to spot that the score of 4 is our mode. Why? Because it occurs the most frequently. Out of 5 people playing, 2 of them scored a 4, while all the other scores only happened once. The mode is great because it quickly tells us the most typical, common result. But wait, here's another really great edge case question from the sources. What do you do when there's a tie for the most popular number? Like, if the mode is basically a popular vote, what happens when 2 values tie for first place? Let's see how this builds our understanding of statistical flexibility. The crucial takeaway here is that a dataset can absolutely have more than one mode. When that happens, we call it bimodal. So if there are 2 2s and 2 4s, both 2 and 4 are your modes. You can even be multimodal with 3 or more. But on the flip side, if every single number in your set appears exactly one time, well, there's no popular vote. In that case, you simply say the data has no mode. Which brings us to the big finale. Section 5, which one is best? Okay, take a look at this crazy data set from our sources. It features massive outliers, like literally 1 million. Imagine this represents the net worth of 5 people in a room, okay? You have a few people with very little, one person with $50, and then boom, suddenly a millionaire. If you want to know the average wealth of a person in this room, how exactly do you calculate it? This perfectly illustrates how a massive outlier can cause the mean to just outright lie to you. If you calculate the mean here, that 1 million pulls the average way, way up. It makes it look like everyone in the room is quite wealthy, which is a completely distorted picture. The median, however, it remains safely anchored at 50. It's totally unaffected by those extreme highs. And the mode? Well, if no one shares the exact same net worth in this group, it wouldn't help us out here at all. This is exactly why knowing how the mean, median, and mode compare is an absolute game changer. Ultimately, knowing how all these compare gives you the power to actually see through the numbers. They each have a valid purpose, sure, but they can also each be weaponized. So, I'm going to leave you with this thought. The next time a politician or a salesperson tries to persuade you with an average, will you know enough to ask exactly which middle they're trying to sell you?